Okay, today's section, 5.4, completing the square. You can see we're going to be using quadratic equations again, using this process to complete the square, and also introduce to you vertex form of a quadratic function to locate the axis of symmetry and the vertex points. So let's get started. In the beginning, we've learned vertex to standard form. Now, the big question is, where's this vertex coming from? We actually discussed in section 2.7, I think it was, all those different transformations and how you move stuff around. So if we have a quadratic and our basic setup for a quadratic, y equals ax squared or kx squared, however you want to say it, that's our basic one that's centered right around 0, 0. So if anything gets moved or transformed from that, then it would get changed based on our rules of transformation to y minus k equals a times the quantity x minus h, that quantity squared. And that would be known as vertex form, because you can look right at it and see the new movement of where your vertex is compared to your original vertex at 0, 0. So if you look at the two examples here, we've got to be able to go from vertex to standard and standard to vertex. This question is all about just, are the two equations equivalent? So without really being familiar with the vertex form, you probably would start rewriting this equation. First, use our binomial squared theorem. So leave the 3 where it is. Square the first. Take the product of the two and double it. Square the last. Continue to combine like terms after we distribute the 3. So final equation here would be y equals 3x squared plus 6x, and then subtract 1. And if you look at that, compare it to the one you have here, we're looking at two identical or equivalent equations. And your work would be your verifying that they are equivalent. So the whole point here is that we should be able to go from vertex to standard. We also should be able to go from standard to vertex. That's the harder one. So we will be working on that. So here are those equations in a little easier form. Vertex form is considered to be y minus k equals a times the quantity x minus h, the quantity squared, where hk is your new moved or transformed vertex from the original 0, 0. The only difference is if you like y by itself, you could rewrite and move that k value to the other side and still have an equation where y is by itself. That's the only difference in those two. Both of those are considered to be vertex form. You have to choose which one you like. I personally like the one on the left here because it mirrors our equation point slope that also had the same setup. So if I looked at my point slope equation, I knew x sub 1, y sub 1 was that point or that changed position, if you want to say now, in our new form. And standard form we know is y equals ax squared plus bx plus c. So those are the two forms we're really working with. So let's review again what the steps were for changing from vertex to standard. It's really just algebra steps. So we start with an equation. We would use that binomial square rule to take care of the parentheses. That would give us the x squared minus 10x plus 25. We would then distribute the negative 3, giving us now negative 3x squared plus 30x minus 75. Then we would move the 2 to the other side by adding its opposite. And doing that would give us our final equation, leaving it in standard form, or y equals ax squared plus bx plus c. So that really is the version that you know. Just got to practice it so we get a little better maybe at the shortcuts, the binomial square shortcut, etc. But I think you'll be good there. It's the other method that we want to talk about. So before we do go to changing from standard to vertex, we need to remember we've been working with that binomial square theorem. And here it is. If I take binomial square, I would square the first, take the product of the two terms, double it, and square the last, and I would get x squared plus 2xh plus h squared. Now that works no matter what. So when we say let's complete the square, we should be able to do that math. So we know this last term, according to this rule, has to be a perfect square number. But look at it. It's related to these. So if we undo that middle term, you're thinking, well, wait a minute. What did we do? We took the product of the two and doubled it. So if we took half of that middle term, we'd have what the number we needed from our binomial square. Then we could square it to get our last term in our trinomial. So let's try it. On this one, x squared plus 8x plus blank. Well, you know that 8x came from 2xh. Well, let's take half of that. Go backwards. Well, that would be 4. But if we square the 4, we get the 16. We now have a perfect binomial square, and it would turn into x plus 4, that quantity squared, and work backwards now and check it. Square the first, take the product of the two and double it, and square the last, and you get exactly what we had here, x squared plus 8x plus 16. So that number we used to complete the square was 16. Let's try another one. We've got a negative 2x. Well, if that was already doubled, to undo that doubling, we'd take half of it. That'd be negative 1x. Square that term, you'd get a 1. And that, again, would give us our binomial square that would turn into x squared minus 2x plus 1. Same thing on x squared plus 30x plus blank. Half the middle term, half of 30, 15. Square that, 225. And you can write it again as a binomial square and FOIL it out, and you would get your new equation. So we've done all of them here where your middle term was even. Now let's try one. She said, oh, that's not nice. Let's do the same math. Let's work it through. So if we get in a predicament like this, we can work the math. So your middle term is 7x. We've been taking half of that. It's hard to take half of 7. Stay away from the decimals. We're going to stick with just fractions. So half of 7 would be 7 halves. Square me. Well, square me means I'm going to turn into 49 fourths. Some of you would like to go 12.25, but again, stay away from that. You're not going to recognize it when you have to come back here and say, all right, what's your binomial square? We know it's an x. We know half our middle term was 7 halves. If we put that half term there and square it, we're going to be able to see exactly what we had. You're not going to have to say, oh, what do I have? 12.25. You know, if I have that number, how am I going to get that? Here, it's going to come out right from the fraction, and you'll be fine. So make sure you have written down, to complete the square, you will be doing what we have been doing, which is taking half of the middle term and squaring it. That's undoing the process we did up top when we said square the first, take the product of the two and double it. So doubling gets undone with a half or a divide by 2. That's where it comes from. So let's now talk about what are the steps for completing the square. Actually, here they are. You might want to start copying them first before we continue. The key piece of this is that first line, everything, of course, must be in standard form. Ours is. Then the next step says divide all the terms by the leading coefficient a value if it does not equal 1. So if a is not a 1, you have to do something first. On this problem, we've got an a value of 1, so we're going to be able to continue. Use the additive inverse to move the constant to the other side of the equal sign. So that means our constant, which is a negative 90, we need to move out of the way. We'll move that by adding 90 to both sides. When we do, that leaves us with x squared plus 18x on the other side. The 90 is gone. Then, next it says, add a blank to both sides, because we're going to be introducing, just like that last slide, a new number after we complete the square that has to be keeping this equation balanced. If we only add it to one side, we don't have that balance, it's going to be wrong, etc. So now we use that process we just did. So find your binomial side, quadratic side. We're looking at the middle term. We need to take half of it and square it. Half of 18 is 9, squared is 81. So we should have an 81 as our term that we add to both sides. So let's go. We did that. Now, it says factor the one side, meaning you just made it a perfect square trinomial, which means you should be able to write it as a perfect square binomial. So ask yourself what goes in here. That would be undoing your thinking. I'm an X, I'm a 9, I'm all addition signs. So again, FOIL that, x squared. 9 times x, 9x, doubled is 18x, square the last, 81. And on this side, left-hand side, we're looking at some arithmetic. The 81 and 90 need to be added, but keep the y first, so we have our equation in vertex form. 81 and 90 gives us a 171. So when we complete this one, we factored, make sure the final equation in a vertex form, and if we look at it carefully, that vertex is staring at us. It is our HK value, and so if someone says, where is our vertex now, we could say -9, -171. If we were originally at 0, 0, this new one has moved to a location 9 units to the left and 171 units down. So completing the square, this was when your A value equals 1. It's very clean, very quick. Now we will do an example where A value is not equal to 1. Step 1, make sure it's standard. It is, following those same steps. If your A value is not 1, you must divide each term by that A value to begin with. Each and every term in the problem. We're going to introduce some fractions, but not all of them. So we will rewrite it with y over 3 equals, we have an x squared, a minus 4x, and a plus 1/3. This is where we now want to isolate that right-hand side and give us that trinomial. So that means the 1/3 constant must come over. It'll come over as a subtract 1/3. Add the y over 3 to it. And we're looking at x squared minus 4x plus, now this is the blank where we're going to add, after we complete the square, a new term to both sides to keep this balance going. Identify the middle term, -4x, half of that, -2, squared is 4. We will add a 4 to make this a perfect square trinomial. If it's a perfect square trinomial, it should be able to be factored into a perfect square binomial. So on the right-hand side, what multiplies to give me my x squared? X does. What multiplies to give me my 4? 2 does. I can see my sign needs to be negative. And again, you can check this by FOILing. Square the first, x squared. Take the product of the two, -2x. Doubled is -4x. Square the last term is our positive 4. So now really all we have to do is clean up this left-hand side, but do not forget that step 1 on this problem is we brought over divide by 3. So we didn't have, so we had an A term of 1. So it's time now to move it back to where it was. So to do that, we're going to times everybody by 3. Now, timesing everybody 3 on the left-hand side is pretty easy to see. If I times everybody on the right-hand side, it means I'm just going to put a 3 in front of that one and only term that there is. So when we simplify now, 4 times 3 is 12. 3 times a -1/3 is -1. And 3 times a y over 3 is y. So 12 plus -1 is 11. And if we put this in the right order, so we get vertex form, we've got y plus 11 equals 3 times x minus 2, the quantity squared. And again, ask yourself, bonus question, what is my vertex? Where has this been changed? If we were at 0, 0, we're now at 2, -11. So you can see exactly where this parabola has been shifted, moved, transformed, whatever you'd like to say. Okay, so this is an example that I would like you guys to try on your own after we've done now 2 different versions, completing the square when the A value is 1 and completing the square when the A value is not 1. It just looks a little different. Let me just slide this up. I think if I do this, it'll look, yep, there we go, like a normal equation. So 6x squared plus 18x plus 12 is the equation I want you to come with, worked out, for class to see if we have any issues. If you do, then we can go over the steps. If not, we should be able to move right along. So that's all for now. You've just learned how to complete the square in a quadratic equation.